All right, this is a video on this Out of the World project. Excuse me there. All right, couple things here. You can ignore this stuff here. These are just the Common Core content standards. This is for the district. Other teachers or whatever want to know what standards will go with this project. All right, so let's look at the objective. In this project, you will compare the vertical motion of a rocket on 3 planets in a distant solar system. Right? So vertical motion. All right. So we're talking about how high the rockets are going. Okay. About height. Now, the vertical motion of a rocket can be modeled by the quadratic model. Quadratic. That's what we've been working with. H of t, remember that's the same thing as saying y, is equal to -1/2 times g times t squared plus v times t plus s. A lot of new variables here, all right? Where h of t is the height at time t, so t stands for time, right here. G is acceleration, so this stands for acceleration. Just underline here, due to the gravity, and v is the initial velocity, all right, and s is the initial height, all right. S is the initial, that's where we're taking off in respect to the ground, all right. So I think the initial height in these problems is going to be 0, which represents the rockets are going to be launched from the ground, all right. So all these variables are explained, all right? All you need to know is a quadratic, all right? So all the stuff we're learning about quadratic, finding the vertex, finding the y-intercept, the x-intercepts, factoring, all that stuff is going to come into play, all right? So you can, don't freak out when you see all these variables here, all right? So let's look at part 1. So we got to complete this chart. What I'm going to do is I'm going to do everything for this planet right here. So the process I use to do this planet, Algebranium, you'll do the same thing for the other 2 planets, exact same steps. Okay, so what you're going to do on each planet, you will assume that the rocket is being launched from the surface of the planet. So that's the reason why h is going to be 0. And that the initial velocity of the ball is 160 feet per second. However, the acceleration due to gravity near the surface of each planet is different. All right. So what we did is we gave you the equation sort of set up. All we have to do is figure out what goes in place of -1/2 g. All right. So we got to figure out what goes there. All right. And in order to do that, okay, so now we're going to figure out what goes here. All you have to do is you're going to take 40. I'm going to take 40. You're going to take 28. You're going to take half of it. So half of 40 is 20. And whatever this number is goes into there. Right? So my equation I'm using for Algebranium is this. It is -20t squared plus 160t. And here, you can put plus 0 if you want, because that's because we're launching it from the ground. All right? So we don't show the 0. So this is the equation for algebra. So you're going to do the exact same process of what I did here for these 2. In other words, you're going to take half of that, goes here, and whatever you have here, you just go ahead and plug it in there. Okay? Now part 2, the calculations. You're going to show all your work to complete the chart below for 3 planets. I'm going to do Algebranium, and you're going to do the other 2 planets. Now for each planet, you will calculate the time required to reach the maximum height. Maximum height, in other words, vertex. All right, so you gotta find the vertex. The maximum height reached, in other words, the vertex, and the time required to return to the planet's surface. Okay? So, what you're going to do is you're going to find the vertex. Okay, so let me explain this a little bit more. Okay, what we're doing is we're taking our rocket, all right? We're launching it, all right? So it's going to go up, it's going to reach its maximum height, and then it's going to come back down until it hits the ground. All right? Okay, let's say this is the ground right here. What we want to do is we want to find the maximum height. In other words, we want to find the vertex. Okay? And then it says, and the time required to return to the planet's surface. Well, in other words, what's the x value here? How long do they go from here to here? How long does it take? In other words, they want to know what's the x value. In other words, we have to find this point right here. Since it's touching the ground, that's called our x-intercept. Okay? So we got to find two things. We got to find the vertex and the x-intercepts. Now remember, there's always two x-intercepts, but we only want to find the one. All right? And I'll refer back to this when we start doing the x-intercepts. All right, so do all calculations on a separate sheet of paper for each planet. All calculations should be neat, labeled, and answer circled. Okay? So like if you notice here, I have one sheet of paper for this planet. You probably want to do the same for the other two planets. You're going to have 3 sheets, one sheet for each planet. Right? The planet, right, it's the equation that you get from, let's see here, from part 1. All right, so we're going to write planet's name, the equation you have here. You're going to write it on a sheet of paper. All right, so now what we're going to do is we're going to find the vertex. Sorry about that, folks. So let's find the vertex. All right, so to find the vertex given standard form, this means we have to use and rewrite the equation again. Right. Vertex, we got to use the negative b over 2a method. Right? So here a is negative 20, b is 160, and c is 0. You notice how this graph is opening down? It should. That's the reason why we have a negative there. And then that from our transformations. So negative b, so it'll be negative 160 over 2 times a, negative 20. So that's negative 40. So let's see, 160 divided by negative 40 is a positive 4. Okay. So, and we're going to take 4. We're going to plug it back into the equation here for t, which we use x's, but here it is just t, so we're going to do negative 20. All right, so I'm taking this part and I'm putting it 4 squared plus 160 times 4. All right, so let's bust out the calculator. See, I'm going to do 4 squared first. So it's negative 20 times 16 plus 160 times 4. All right, so negative 20 times 16 gives me negative 320. And then 160 times 4 is 640. And then therefore that gives me 320. Okay, so my vertex is 320. Okay, now Let me interpret this. So this right here, the vertex is 4,320. All right, so let me interpret this. I just said that, didn't I? All right, let's go back to part 1. All right, so T, remember, my vertex is a form of T. So this right here, what used to be X, is T. That's time. All right, for what? 4 minutes, 4 hours, 4 seconds, what? Let's look here. Let's see if we can find it. Let's see here. What will be our time? Right here. It says in part 1, the initial velocity of the ball is 160 feet per second. So we're dealing with seconds. So to reach the height of the rocket is 4 seconds. Right? That's what the X value, that's what it means. It takes 4 seconds to reach the highest height. All right? Nope. I'm sorry, that's not the height. It takes 4 seconds to reach the height. And let me do that again. So it's 4 seconds to reach maximum height. All right, that's better. Now, what's 320? Well, that's the height. 320 is the height. Now, is that feet, inches, what? So if we go back to part 1 again, see where they're using feet, 160 feet per second. So that means feet. All right, so it takes 4 seconds to reach a height of 320 feet. Once it goes past 4 seconds, it starts falling. All right, so we're no longer getting higher. All right, so that's what the vertex means. Now we want to know, the second part of the question here is the time required to return to the planet's surface. In other words, what's the X value right here? Or T value, or X, whatever you want to call it. All right? Because what's the height? All right? Remember, seconds and height. That's how the vertex is going. So if I want to find this point, it's going to tell me how many seconds until it reaches the height right here. In other words, the height here is 0. That's why it's called the x-intercept. How long does it take to hit the ground? All right, so that means we got to find the x-intercepts. All right, this one should go a little bit quicker. All right, so here we go. Now, factoring, there's 2 terms, so we're going to use the GCF. All right, so I'm going to factor out a negative 20t, because remember, I always like the first term to be positive. So negative 20 divided by negative 20 is 1.
May I have attention please? 3 o'clock activity buses will be arriving momentarily. 3 o'clock activity buses will be arriving momentarily. Thank you.
I gotta hurry up, the activity buses are coming. All right, so I get 1t plus 160 divided by 20 gives me 8. Set equal to 0, so negative 20t is equal to 0. So t is equal to 0. Well, we don't want that because that's this point over here. That's the initial place where it's taken off. We don't want that. All right, so we got t plus 8 equals, t is, oh, factor out negative. This should be a negative, excuse me. Negative. So it becomes positive 8. So it takes 8 seconds. Okay, I will finish up the rest of this on the next video.